Mars has captivated humanity for centuries, from ancient astronomers who charted its movements across the sky, to modern scientists who dream of setting foot on its surface. The red planet has always sparked our curiosity and imagination. It's a rusty red dot in our night sky, a celestial neighbor that has fueled countless dreams of exploration. For generations, people have wondered what secrets Mars might hold, and whether it could one day become a new home for humanity. But Mars is more than just a pretty sight. It's a scientific gold mine, offering clues about the formation of our solar system and the processes that shaped our own planet. Studying Mars helps us understand Earth's past and future. By comparing the two planets, we can learn how planets evolve and what makes Earth so unique and precious. It could even hold the key to answering one of humanity's biggest questions: are we alone in the universe? The search for life on Mars is not just about finding microbes, but about understanding our own origins. Mars was once a very different place than it is today. Billions of years ago, it had a thicker atmosphere and liquid water on its surface. It may have even been habitable, with rivers, lakes, and perhaps even oceans that could have supported life. Today, Mars is a cold, dry desert, but signs of its watery past are etched into its rocks and landscapes. Ancient riverbeds and minerals that form in water tell the story of a planet that once had the conditions necessary for life. NASA's Mars missions are designed to uncover the secrets of the red planet. Rovers and orbiters are our robotic explorers, tirelessly searching for evidence of water, organic molecules, and the building blocks of life. Scientists want to know if life ever existed on Mars. They analyze soil samples, study the planet's chemistry, and look for signs that microbes might have once thrived there. They want to study its ancient climate and geology, piecing together the history of Mars from the clues left behind in its rocks and dust. And they want to learn if humans could one day live on Mars. Could we build habitats, grow food, and survive on this distant world? The answers could shape the future of human exploration. These are ambitious goals, but they are within our reach, thanks to decades of innovation, teamwork, and the relentless spirit of discovery. With each mission, we get one step closer to understanding Mars and our place in the cosmos. The red planet continues to beckon, inviting us to explore, to learn, and to dream bigger than ever before. In February 2021, the Perseverance rover touched down on the surface of Mars, marking the beginning of one of humanity's most ambitious missions to the red planet. After a journey of nearly 7 months through deep space, Perseverance arrived with a singular goal: to search for signs of ancient life and unlock the secrets of Mars' past. Its mission? To explore Jezero Crater, a 28-mile-wide impact basin that scientists believe was once a vast lake, fed by ancient rivers billions of years ago. This crater is a time capsule, preserving evidence of a watery world that might have been hospitable to life. Why Jezero Crater? Because where there was water, there might have been life. The dried-up river deltas and lake beds here are prime locations to search for biosignatures, chemical or physical traces left behind by living organisms. Perseverance is the most sophisticated rover ever sent to Mars, equipped with advanced technology and tools never before used on another planet. It's equipped with a suite of scientific instruments designed to study the planet's rocks, soil, and atmosphere in unprecedented detail. These instruments can analyze the chemical makeup of Martian materials, search for organic compounds, and even create oxygen from the thin Martian air. The rover is also searching for signs of ancient life, collecting rock and soil samples along the way. These samples are carefully sealed and stored, with the hope that a future mission will one day return them to Earth for deeper analysis. One of Perseverance's most exciting discoveries so far is the presence of organic molecules in Jezero Crater, complex, carbon-based compounds that are essential ingredients for life. Organic molecules are the building blocks of life as we know it. Their discovery on Mars raises fascinating questions about the planet's potential to support life in its ancient past. While their presence doesn't necessarily mean that life existed on Mars, it's a tantalizing clue that encourages scientists to keep searching. Each new finding brings us closer to understanding whether Mars was ever home to living organisms. The rover has also found evidence of ancient hydrothermal vents in Jezero Crater, places where hot water once surged from beneath the surface, creating environments rich in minerals and energy. On Earth, hydrothermal vents are teeming with life, supporting unique ecosystems that thrive in complete darkness, far from sunlight. Could these Martian vents have once harbored microscopic organisms? If life ever existed on Mars, these would be some of the best places to look for its traces. Perseverance is collecting samples that might hold the answer, preserving them for future scientists to study. Each core sample is a piece of Mars history, waiting to reveal its secrets to the world. Perseverance, NASA's most advanced rover, is diligently collecting Martian samples, carefully drilling into the red planet's surface and gathering precious soil and rock. Each sample is stored in a specially designed sealed tube to preserve its integrity for the long journey ahead. But as advanced as Perseverance is, it can't analyze these samples in detail on its own. The rover lacks the sophisticated laboratories and powerful instruments we have here on Earth, tools that can reveal the tiniest secrets hidden within Martian rocks. To truly unlock the mysteries of Mars, we need to bring these samples home, where scientists can study them with the full arsenal of modern technology. That's where the Mars Sample Return or MSR mission comes in, a bold plan to retrieve Perseverance's samples and deliver them to Earth. MSR is one of the most ambitious and technically challenging space missions ever conceived, requiring years of planning and international teamwork. The mission will send a series of spacecraft to Mars, including a lander, a fetch rover, and a rocket to launch the samples off the Martian surface. These precious tubes will then be transferred to an orbiter, which will carry them across millions of kilometers of space back to Earth. MSR is a complex, multi-stage operation, demanding cutting-edge engineering, precise timing, and collaboration between NASA, ESA, and scientists worldwide. The scientific payoff could be enormous, potentially answering questions about Mars's history, its geology, and even the possibility of ancient life. Imagine holding a piece of Mars in your hand, a rock that's traveled across space and time to reach us. Scientists will analyze its composition, structure, and chemistry in ways no rover could ever achieve. With these samples, we might even find evidence of ancient Martian life, microbes that once thrived in Mars's distant past. The Mars Sample Return mission has the potential to revolutionize our understanding of the red planet and forever change our perspective on life and our place in the universe. The Mars Sample Return mission is a monumental undertaking. It's also, well, incredibly expensive. The original cost estimate was around $3 billion, but that number has ballooned to somewhere between $8 and $11 billion. These rising costs have led to delays. The mission was originally slated to launch in the 2020s, but now it's looking more like the 2030s or even the 2040s. And then there's the competition. China is also developing a Mars Sample Return mission called Tianwen-3. They're aiming to launch in 2028 and could potentially return samples by 2031, beating NASA to the punch. NASA is under pressure to find faster and cheaper solutions. They're partnering with private companies like SpaceX and Lockheed Martin to explore new technologies and approaches. It's a race against time and a test of human ingenuity. While we prepare for future Mars missions, scientists are hard at work right here on Earth. They're simulating the challenges of living and working on Mars in special facilities. One such facility is the Human Exploration Research Analog, or HERA, at Johnson Space Center. HERA is a 3-story habitat designed to mimic the conditions of a future Mars base. Crews live inside HERA for weeks or even months at a time, conducting research and performing simulated Mars walks. They experience communication delays, limited resources, and the psychological challenges of isolation and confinement. These simulations are crucial for understanding the challenges of human exploration and preparing astronauts for the rigors of a Mars mission. Space exploration is a global endeavor. No single nation can do it alone. NASA recognizes this and is actively collaborating with other space agencies around the world. The European Space Agency, or ESA, is a major partner in the Mars Sample Return mission. They're contributing a rover to collect the samples cached by Perseverance and a spacecraft to ferry them back to Earth. Japan, Canada, and the United Arab Emirates are also making significant contributions to Mars exploration. These international partnerships pool resources, expertise, and perspectives, accelerating our progress toward understanding the red planet. The quest to understand Mars is more than just a scientific endeavor. It's a testament to the human spirit of exploration and our insatiable curiosity about the universe. It's about pushing the boundaries of knowledge and inspiring future generations. If we find evidence of past life on Mars, it would be one of the most profound discoveries in human history. It would mean that we are not alone in the universe. It would change everything. But even if we don't find life, the knowledge we gain from exploring Mars will be invaluable. It will help us understand our own planet better and guide our search for life elsewhere in the cosmos. Mars is a stepping stone to the stars, and the journey has just begun.